Swaroop, Sudha, she didn't give 0. Gnaneshwar,
We have TB, we have generator with and also we are connected. Pointer is used for because it is static interface.
log.
In Verilog, we can the main thing is reusability, ma'am. We cannot use the test image in the where we cannot reuse the test.
Last session, I told that everyone to join via laptop. But you can come prepared, not a problem. You can come prepared. You do not have to worry. We are having C language in the Verilog also you have used. Okay, which are new. We will concentrate on that. Remaining things I will just brush through it, and all these are important for your array. So associative array already, as I discussed last session. Dynamic array, associative array. What is the difference means? Just a moment. Let me. See, dynamic array and associative array. So what is the exact difference? Actually, I told three differences, if you remember last session, right? So those three differences, first you can tell about the syntax. Okay, coming to the syntax, here you can see for the associative array, so same data type, name of the array which is user defined, but here inside the square bracket it is not empty. We are having again the data type. What data type? Index data type. So usually the array looks like this. So here we are actually writing the elements or the values. Okay, here we will write the addresses, correct now? So for this address or for this index also you can have a data type. Ma'am, can we have a string here? Yes, you can have a string, you can have a bit, you can have a byte, whatever the data types you want to keep in the index, definitely you can keep it here, which was not present in the other type of arrays. Like in the fixed array, in the dynamic array, by default we are going to keep int. By default we can't change, that is not just a numerical, right? But here we are having an what liberty to keep the different data type indexes also. Okay, so whatever the data type is there outside, that is a data type of the element. Whatever the data type that is present inside the square bracket, that data type is for the index or the address. Okay, so this is how you are actually writing the syntax of the associative array. Okay, next, coming to the memory difference. Memory, how we can save the memory means, see in the dynamic array, when you allocate a memory like a new of 10, like this, when you allocate 10 memory allocations, it will get occupied in the sense, even though if you do not write anything into that address locations also, see this is 1 2 3 4 5 dash 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 till 9, I have a 10 locations. Okay, even though if I don't use this location, still the memory is consumed unnecessarily. See, I'm not even using it. 444 100, only 3 locations I have used, remaining locations I didn't use, but still the simulator will actually consume the complete memory. But in the associative array it's not like that. Wherever you are writing the data, only that particular locations are consumed, remaining locations are not consumed. That is associative array. So here what happens here in the industry, in the catch type of projects means where the project will be having a limited memory, means less memory they have. In that case we will definitely use associative array, because unnecessarily I do not want to waste my memory. Okay, in the dynamic array, even if I use that space, even if you do not use that space also, that memory is consumed in the project. But here it is not like that. Wherever you are writing the element, only that particular space is only consumed in the associative array. That's about second difference. And third difference, you can write about the, you can list out the inbuilt methods of the dynamic array and inbuilt methods of the associative array. Okay, so now let us further discuss. Here you can see, so string I have kept. Okay, the data type of the index is string. So according to that, see, In red is a address, that is an address name. Okay, in the red address I'm having the value called 20. Okay, next green address. In the green address means specifically in that particular location you can write, you can write the data. Means here basically we are saving the memory. Here you can see, okay, here I'm not writing anything, still the memory allocation is happening in the dynamic array. But in the associative array, wherever I am using the space, only those space are calculated during the project memory calculation. Okay, this is where we are actually saving the memory. Okay, next, these are the inbuilt methods that are present in the associative array. In dynamic array, only three inbuilt methods were there, right? Now, new with the size was there, and size was there, and the delete was there. And main importantly, when we are using the delete inbuilt method in the dynamic array, we used to delete the complete array. Correct? Na? Here, not like that. If you want to delete a particular address element, definitely you can delete. That is another advantage. Okay, so let us see all these in the code. Okay, so let me open the code. All these once let us execute it. So the first question, difference between, so today's was 6th. I guess so. Even in the last session also have written. Anyways, difference between dynamic and associative array. Dynamic and associative array. 3 points are there. Okay, and individually they may also ask you to list out the inbuilt methods of associative array. Inbuilt methods of associative array. That might be one question. Okay, third question again, next, list out the inbuilt methods of queues. Our next topic is queues. So in the queues also they will ask you to list out the types of queue, inbuilt methods of queues. Okay, and one more is types of queues. Types of queues. So these are your 4 questions. First let us discuss about the associative array. Let me complete it. Okay, yes, I guess I have given all the codes for you people. No, just one second, let me check what all codes I'm explaining in the live session. Already I have allotted in the Google Classroom. Once again, let me check. Even practice codes also I have given, I guess, right? No, live session course, practice course, yes. Okay, so now you have to download it. Okay, yes, and still I have not started with the assignments. I will start. Okay, first that's what, today, tomorrow, from Monday onwards or from Sunday onwards I will start allocating the assignments as well. Okay, assignments will not be tough assignments. Your, see, every day whatever the interview questions I am giving now, that itself is like an assignment. Okay, but related to some other, means the, I'll ask to sir, okay, what project is included or not included, what exactly is the scenario, I will once ask to sir, and then I will start allocating the assignments. Okay, yes, but till Sunday first let us complete the syllabus part. Okay, yeah, here bit 7 down to 0, array and int, means index is also the int only here. Okay, next, here you can see 5 in the 5th location I am allocating the value has 2, in the 10th location 4, in the 7th location 6, in the 20th location 10. But here, okay, randomly in the random addresses I am writing the element, that is okay. But how the simulator will understand, you know, so it will understand like, if I draw the diagram, so if I draw the diagram of this, so it is like, in the ascending order it will be arranged, in the ascending order, because see, in the, in any of the simulator the memory will be in a proper order. Correct na? First in the 5th location what is stored, 2. Next, 10th location it will not come, 7th location, because after 5 6 will come. In the 6th location I didn't write anything. In the 7th location I have written 6. Okay, this is done, this is done. Next, in the 10th location we are having 4. Okay na? Next, ninth, no, no, first ninth location, ninth location I'm having 8. In the 10th location I'm having 4. Okay, next in the 13th location I'm having 12, in the 20th location I'm having 10. Like this, see, 5, 7, 9, 10, 13, 20. No matter, you have written as per your choice, but when the data is getting arranged, when the array is getting arranged, it will get arranged according to the ascending order of the address. Okay, so this thing you have to remember. Okay, yes. Okay, now for each of array of I am trying to just display. Okay, so let me run the code. Just I have declared it and I'm trying to run the code. So you can see, observe whatever I have told here order wise. Okay, 5, 7, 9, 10, 13, 20. The same order it will be followed here. See here, 5, 10, 9, 10, 13 and 20. In ascending order I got. But I didn't write in ascending order. Randomly I have written the address locations. But here I will get it in the ascending order. Okay, next. What I'm trying to print? I'm trying to print the size and the num. See guys, size, num. Both are same only. Okay, size means it is telling the size of the array. Num means it is going to tell how many elements are there. Both are similar, no, in the associative array. 1, 2, 3, 4, 5, 6. 6 is there. See, size is also 6. Number of entries means how many elements are there. 6 elements are there. Okay, next I am trying to check in the 7th location, is there any element that is existing? Yes, in the 7th location I have written some data, correct na? So for this I will get a true condition. Here an element exists at index 7. Okay, in the 8th location, is there any existence of element? No. In the 8th location I didn't write anything, so I will get a false condition. Okay, 1 minute. An element doesn't exist here. Here an element doesn't exist in index 8. Okay, next, first of index, which is my first index, 5th, right now, that is what I'm trying to get here. 5. Okay, means according to the ascending order it will ask. Okay, which is my last index. Last index is here, it is actually 20, not 13. It is 20. According to this diagram, if you see what is my last index, it is 20. Okay, so you have to always think in the ascending order arrangement. You write as per your choice, but when you are using the inbuilt method, it always sees according to the ascending order. Okay, next, for example, if the index is 9, for what is the previous index for this diagram? If the index is 9, what is the previous index? It is 7, correct na? So let me see that. Yes, previous index of 9 is 7. Okay, next, if the where is that? If the index is 10, okay, what is the next index? If the index is 10, what is the next index? It is 13, right? So let me see, am I getting it? Yes, the next index of 10 is 13. Okay, next, so I want to delete. See, last time what I did in the dynamic array, I have deleted the complete array. Means I was not having any option to delete a particular element. But in the associative array, I can delete a particular element. Means in the 7th location, in the 7th address, whatever the element is there, delete it. That's what it is written here. Delete of 7th location. Okay, in the 7th location, what we have? We are having 6, correct na? We will delete this now. Okay. So after deleting, again I want to print, obviously. Okay, if I print, see, here I have got the elements, but without the 7th element I have got. Okay, next, if I want to, if can I use only delete method? Yes, you can use. When you use only delete method, a completely it will get deleted and the size will become 0. Okay, means complete array will get deleted, just like dynamic array. Okay, here you have two options also. You can delete a complete array, or you can delete an individual element in the array. Both options you are having here. But in the dynamic array, we were having only one option, that we have to delete a complete array. That was the thing. Okay, and after completing and after deleting a complete array, if you check the size, obviously that size will be 0 here. Okay, so is this no associative array clear? Is this code clear? Any doubts here?
Ma'am, one doubt, ma'am.
Yes.
Ma'am, when we are assigning for same index another value, what will be the value, ma'am?
I didn't understand. Overriding.
Means,
Overriding will happen. Means you are telling that for 5th address you have assigned some value. After some time you want to change the value. Means overriding will happen. That's it.
okay, ma'am.
Hmm. Not only here, wherever in whichever the array concept you take, that might be in the queues on dynamic array, wherever it, see yesterday in the dynamic array also we have discussed the same, no? Like if you want to retrieve the old data, you can retrieve, or else you can overwrite that data. Means if the new memory is created, if you want to retrieve the old data, you can retrieve. No, if you are not interested in old data, you want to freshly write the data, means if you want to overwrite the old data, you can overwrite as per your choice. Okay.
Okay.
Next. Okay, others. What about others? Is this code clear? Please respond in the chat box.
Ma'am,
Huh.
if we give index type a string, how it will arrange, ma'am?
How it will arrange lexicographical ordering? Very good question. So here what Jyoti is asking is, here we are telling ascending order, right? If we give strings A, B, C, D something, we will write some right, no, red, green something we will write. So according to the lexicographical ordering method, simple. I mean alphabetical order. It is going to arrange the array. Okay, Jyoti, is it clear?
Yes, ma'am.
Okay, always that's what in the strings concept only that usually we will call lexicographical technically, but normally in general language if I tell, that is nothing but alphabetical order. Okay, but there is a small difference between a lexicographical ordering mechanism and the alphabetical. Alphabetical means what? I will consider only first letter, means J, Jyoti, Gnaneshwar, Gopi, Anita, like this the names are there, no, only first letter I will consider. But in the lexicographical ordering mechanism, for example, Gopi and Gnaneshwar, two GG are there in the first bit, right now. Then I will check with the second bit also, second what we call second letter also. If that is also same, I'll go to the third letter. That is how the lexicographical ordering method will happen. Okay, almost also in the same way. If you use in the software alphabetical way, means also the same way it will take. Okay, but technically you are supposed to tell it as lexicographical ordering method. Okay, that was a good question. Okay, so others, is there any other questions related to associative array code? Please respond in the chat box. Is it clear? Okay. Now coming to the next concept, that is queues. Okay, so queues is more or less it is like FIFO. Okay, not more or less, almost it is like FIFO only. Okay, FIFO means what? We have a space, we have a memory. Okay, that is also one kind of memory, FIFO, LIFO, whatever. Okay, so here basically FIFO, how it behaves, whatever data is sent here, what first in first out, means if I send 1, okay, that will be stored here. Okay, if I send 3, the 3 will come here, 1 will be shifted to the next location. Next, if I send 44, the 44 will be occupying here, 3 will be shifted here, 1 will be shifted here, correct? So this is what is actually happening in the queues also. Okay, so this is one kind of FIFO kind of memory only you can think. Okay, and what is the syntax? Data type, where is it? Data type, name of the queue, that is user defined, and here we are having inside the square bracket we will be having a what is this dollar symbol. Okay, and here again we are having two types. Okay, bounded queue and unbounded queue. See, this bounded and unbounded is a general word, because in the further concept, mailbox concept also, I will be teaching what is bounded and unbounded. Okay, there also you will be having the same thing. Okay, bounded mailbox, unbounded mailbox you will be having over there. Okay, so here you are having because this bounded and unbounded is a general, that's what I'm trying to tell. Okay, so bounded means what? Always we are going to specify the size, that is called as bounded. Unbounded means infinity, means there is no limitation of the size, that is unbounded. Okay, see, whatever the syntax you are seeing here, it is an unbounded, means I didn't specify any size of the queue, simply I have written dollar, that's it. How much ever space you want you can take, that's your choice. That is unbounded. Bounded means here you can see I have written dollar 255. Dollar means what? It can start the addressing from anywhere. I can start from 0, I can start from 10, I can start from 150, I can start from 100, that's my choice. But I have to stop at 255, means maximum elements which I can store in this particular memory is 0 to 255, which means what? 256 elements I can store. It is maximum I'm telling, but it is dollar na, I can't tell what is the starting address. It's my choice. I can start from 2 also, from 10 also, from 0 also, from 200 also I can start. That's my choice because I have just written dollar. Dollar means it is not known actually, first of all, okay, but I'm stopping the address at 255. Okay, means from 0 if I start also, 0 to 255 if you want to store also, maximum 256 elements I can store in this particular queue. That's how it is. Okay, like this, if we specify any size, then that is called as a bounded queue. If we do not specify any size, that is called as unbounded queue. Okay, so this one you people have to remember. Types of queue, that's what I told even in the interview question. Here, types of queue. Okay, fourth question. Okay, so here some another code is there. That's what existing code. Okay, you can go through this once I complete the session. Okay, extra codes are also there in the slides, so that once again after the session you can go through it. Associative array related. Okay, yes. Next, so as I told, that's what the FIFA example only they are giving. Push friend. So here mainly in the queues we are having four main important inbuilt methods. Of course, we are having totally four, I think seven we are having. In that, four are very very important. Whenever they are asking you people the inbuilt methods of the queues, these four inbuilt methods compulsory you have to tell. Those four inbuilt methods are push friend, pop friend, push back, pop back. Means push means insert the element from the front side of the queue, and if you want to remove the element, yes, you can do that also. Pop front. Here, pushback means insert the element from the back side of the queue. Okay, pop back means from the back side of the queue you are supposed to remove out the element. You are going to extract the output from the this end, this corner of the or else this we can consider it as LHS and RHS. Okay, from the RHS of the queue you can extract the element outside. That is called as pop back. Okay, see here I'm writing dash dash dash, which means what? Infinity. But here I have specifically given some size, that is called as bounded. Okay, the length of the queue is here 8. Here it is infinity, that is unbounded. Okay, here it is bounded. Whenever I give the specific size, that is called as bounded. Okay, yes. So this one you people have supposed to make a note, and here of course you can see. Okay, so size, delete of index, same. In the associative array also we had a same inbuilt methods. In the dynamic array also same inbuilt methods. But here these four are very very important. This I'll show in the code. Okay, next. In the particular index, if you want to add some element, yes, you can add. But always remember here, if you are adding some extra element, the old element will not get overridden. It will get shifted to the next location, because that is how FIFO will work. Correct? No? Suppose if this is my element, this is my queue, I'm having 44, 88, 100, 101. Okay, this is location 0, 1, 2, 3, 4. Okay, suppose if I write insert first comma 1001. If I write like this, what it means? In the first location write 1001. Okay, then what happens for 44? Will that get overridden? No, it will. I will write 1001 here. 44 will get shifted to the next location. Means now the array will look like this: 1001. Okay, 44 will get shifted to the next location, 88 will come here, 100 will come here, 101 will come here, like this. These 44, 88, 100 and 101 will get shifted to the next location. That is a queues concept. In associative array, in the dynamic array, in the enum and all, if you want to insert an element, that insert was, means if you want to write any element, that particular element will override the previous element. Here it is not like that. It is totally behaving like a FIFO. Whenever I'm going to add another number, that particular number what was present in that previous location, it will get shifted. This one you have to remember. Okay, yes, except q, remaining all the arrays will be overriding the previous value. Okay. So here, so we have a small queues example. Okay, module and module, I have taken one queue. So dog, lion, tiger, donkey, rabbit. Okay, so I'm just trying to display the complete queue with the help of a name of a queue. Okay, and I'm trying to check the size. What is the size? 1, 2, 3, 4, 5. Size is 5, and all the elements will be printed because I'm using percentage p. See, when I'm using percentage p, I need not declare specifically that is percentage yes or percentage D or percentage H, I need not declare. Simply I can write percentage P. When I use percentage P, automatically it is going to give me the data output. 1 second, I'll plug in. 1 minute. Okay, so here you can see number of animals is 5, sorry, that size is 5, and what all 1 2 3 4 5 elements is there that got printed here. Okay, next, insert. In the first location, insert a cat. What is the first location? 0 1 2 3 4. In the first location, what is there? Lion is there. Lion will get shifted to the next location, and in this location cat will come and occupy. Okay, see, dog, cat, lion, tiger, donkey, rabbit. That lion got shifted to the next location. Now total memory is 6. Okay, see, the memory is expanding and the memory is also decreasing. Okay, we can decrease the memory and we can increase the memory anytime. In the dynamic array, in the associative array, in the queues, the memory can increase or the memory can decrease at any point of time. Okay, next, delete the third element. Now here, which is the third element? 0 1 2 3. So this tiger I want to delete. After deleting, what will be the size? 1 2 3 4 5 5. Okay, so dog, cat, lion, tiger I have deleted, donkey and rabbit I got. Okay, next, now animal dot pop front. From the front side of the queue, what is my, I have deleted the tiger and I have got this one. Okay, deleted the tiger, this is my output. From here, next I want to pop front. In the first of the array, what is the dog? Now dog I am popping out. Okay, now what is left out? Cat, lion, donkey, rabbit. Cat, lion, donkey and rabbit. Okay, this is my present queue. Next, again I have supposed to, okay, push front. In the front side of the queue, I have to insert the deer. Okay, see, I have inserted deer. Okay, and whatever the old elements was there, that got shifted to the next address. Okay, now the size is 5. Okay, next, pop back. So back side, what is the rabbit is there, I will pop back. Next, that will be printed. Okay, next, again push back. Push means insert deer in the back side of the queue. Okay, in the RHS of the queue. So if you are inserting a total array, sorry, queue size will be again 5. Okay, so that's how you people are actually working on this particular FIFO or queue. Both are same. Okay, so is there any confusion here with respect to the inbuilt methods of queues?
No, ma'am.
Others, please respond in the chat box.
Ma'am, I have one doubt, ma'am.
Yes.
Ma'am, if we are using bounded queue means it is memory is fixed, no, ma'am. If you want to insert an element, how we will insert, ma'am?
That's what here I don't know. Okay, here I shifted. Okay, so if I have a, for example, 0, 1, 2, 3. Okay, I have written 44, 55, 105, and 100. Now I will write insert. In the second location, I want to insert 22. Okay, so in the second location, I will insert 22. 105 will shift to next. 100 will get disappear because I have a limited space. No, that's how it
Okay.
is.
Okay.
In the unbounded, I can expand the memory, but in the bounded, it's not there in my hands. I can't expand. So whatever the data got shifted, last data will get vanished. That will be eliminated, and whatever present it is there, that will get shifted.
Okay, ma'am.
Yes. Any other questions? Others? Okay, I think one simulation code is also there. 1 second. Same, a kind of a small code. Okay, so module and module. So I'm just declaring one queue. Again, it's an unbounded queue. Okay, so and one more queue also I'm declaring. Two queues I'm declaring. Okay, first queue, it is bit. No, I have given 0 1 2 3. it is next is string. I have given red, blue and green. Okay, so two strings I have given. For two strings also I have declared the initialized the values. Okay, then I'm trying to print both. Okay, first one using percentage d. No ma'am, I want to use percentage p, means that's the best thing. Okay, when you use percentage p, you do not have to declare what kind of element it is. Okay, whether it is what data type, you do not have to worry. But if you want to write percentage d and percentage yes, that is also correct. Okay, so it will get printed whatever the norm whatever you have initialized first, that will get printed. Okay. 0 1 2 3 and red green, sorry, red blue green, red blue green, that got printed. Okay, next what I'm trying to do, in the first location insert orange, in the second queue in the first location I want to insert orange. In the zeroth location red is there, in the first location orange I will insert, then next blue, next green, means blue and green got shifted to the next further locations. That is my prediction. Okay, next in the second queue delete the third element, 0 1 2 3, it is green now, I will delete green. So what is left out, I left out is red, orange, what is it, blue, red, orange, blue. Okay, so this should be my output. Let me check. Red, orange, blue, green, red, orange, blue, green, next red, orange, blue, red, orange, blue. Okay, that's it. Okay, so that's how it is. Okay, it will get shifted, which means we are increasing. Usually bounded queues we will not take. Okay, because in always what happens is in the dynamic and in the associative and in the queues concept, we always want to change the size, means we want to utilize the complete efficiency of it. If you do not want to change the size, okay, then go for fixed array, that's the best thing. Okay, but one more disadvantage is in the fixed array, you are not having so many inbuilt methods that is supported. That is why in the queues we have kept one bounded option. Okay, means in the scenario where you want to limit the size, but you also want to push and back, push front, push back, shifting operation, all these if you want, you can't go for fixed array. If you choose fixed array, in the fixed array so many inbuilt methods are not there actually. That is why we are actually coming to the queues. In the queues one concept we kept, extra concept, that is bounded queue. Okay, yes. Okay, okay, that's about the queues concept. Okay, next, array manipulation methods. So this is also easy, but just let us take some 5 minutes break and we'll come back. Okay, don't leave the session, stay in the call. Okay, I'll just take some 5 minutes break. Okay. Yes guys, are you people there? Are you people there? Please respond yes, yes. Others? So let me continue with the array manipulation methods. Okay, see, easy because only these four inbuilt methods which are unique for the queues. Okay, so this you have to remember. And between dynamic arrays, queues and associative array, delete and size is common. Okay, delete and size both are common, but here particularly delete of a particular element is available in the associative and the queues, which is not available in the dynamic array. Means in the dynamic array, if you want to delete also, complete array you have to delete. Okay, only one particular location you can't delete, but in the queues and associative array, one particular location, one particular index also you guys can delete it. Okay, yes. So array manipulation method, if three is enough, but totally as per the industry standards, I'll teach all the four. Okay, four types are there: array ordering method, array reduction method, array locator method, and this is extra: array iterator, index querying. Okay, so in the interview, these three if you tell, that is enough. Okay, again here you people have supposed to memorize so many inbuilt methods. Okay, so what are those? In the in the ordering array ordering method, we are having reverse sort, shuffle. Means when the array is created, if you whatever the array elements are there, if you want to reverse it, okay, see, I'm telling about the elements, not the index. Okay, you have to be very careful here. The interviewer will try to confuse you. I'm not speaking about the index, I'm speaking about the elements, the values that we write inside these boxes, that I'm speaking about. Okay, if you want to reverse it, if you want to sort means arranging in the ascending order, R sort means arranging in the descending order. Okay, shuffle means randomly I'm going to shuffle the data. Okay, so what exactly will happen here, let me show you directly with the help of an simulation example. Okay, and as I told, you can use any array. Okay, so if you open and check in the session, in the live session, I will teach any one. Okay, I will teach either fixed array or dynamic array or associative array or queues, any one array I will take. As I told, see, same inbuilt methods I'm using in all the arrays. In the dynamic array also I'm using, in the fixed array also I'm using, in the associative array also I'm using. Wherever you want, you can use. Okay, yes. So one second, reverse hand, this one I'll take. Fixed array, ordering method. Okay, I have taken fixed array. You can even work with the queues also, in with the associative array also, with the dynamic array also. It is there in the code file. Okay, when you are practicing, you can analyze everything. Okay, yes, here I have taken 4 arrays. Okay, 4 arrays, each of size 4. And here, as you people know, the memory is fixed. In the fixed array, memory is fixed. I'm not going to increase it, I'm not going to decrease it. Okay, now array 1, array 2, array 3, I have array 4. I have initialized some of the values here. Okay, next, first I'm trying to display array 1 dot reverse. This array 1, whatever it is there, 0 1 2 3, it should get reversed, means 3 2 1 0, like that the array has to get arranged. Okay, so let me run it one by one only, I'll show. So this is the original array. Okay, here you can see 3 2 1 0, it has reversed. Okay, what is this? I'm speaking only about the this one, elements, not the addresses. Okay, next, sort method means ascending order. Okay, see here, so it is 2 3 1 0, randomly some values I have given for array 2. Okay, in ascending order it is arranged, 0 1 2 3. Okay, I'm telling again elements. Okay, next, reverse sort means descending order. Okay, so here 2 3 1 0 it is there. Descending order means larger number to a smaller number. Okay, 3 2 1 0, it is arranged. Okay, next is shuffling. Okay, array 4 dot shuffle. Okay, so that shuffling, randomly we are going to shuffle the data, that's it. Okay, so this is very simple array ordering methods. This array ordering methods, it will work in all of the array concepts, not only in the fixed array. Okay, so here are their examples, dynamic arrays, queues, all these examples I have kept in the file. You can once go through it. Okay, next, array reduction methods. Array reduction methods, again there are 3 types: sum, product, and or XOR. Okay, sum and product is easy, which means whatever it is there, sum means 1 plus 2 plus 3, it will give the answer. 1 plus 1 into 2 into 3, it will give the answer. That is what is called as sum and product. Sum and product is easy. But what about and or XOR? And or XOR, you have to do bitwise and bitwise or bitwise XOR. If you have forgotten, let me just revise that also. Bitwise, I'm telling, bitwise operations here. So if I, in the bitwise, if I take and operation, okay, I will tell for and, you can revise for or and XOR. Okay, 0 0 0 1 1 0 1 1 means it is 0 0 0 1, right? Now your number is 2 and 3. First write that in binary. Okay, because I want to do bitwise. Bitwise means I have to write that particular numerical. This means if I want to do 2 and of 3 bitwise operation, if I want to do, I have to first write that in the binary. Okay, so I have written in binary 2 and 3. Okay, bit by bit. So 0 and 1, what is the answer? 0 1, it is 0. Okay, 1 and 1 is 1, 0 0 is 0, 0 0 is 0, means column by column, from right hand side to left hand side, column by column we are supposed to do the operation. Okay, and finally we got this answer, 0 0 1 0. That answer is 2, means if I do the bitwise operation for 2 and 3, my answer will be 2. That's how you are supposed to do it. Okay, suppose if you have 3 numbers, then what to do? First, do the bitwise operation for 10 and 9, you will get one answer. Okay, that answer and 8, you are again supposed to do the bitwise and operation. Okay, so here first 10 and 9. Okay, 10 and 9, you should do the bitwise operation of and, you will get one answer. That answer, and what is the value of C? It is 8. That answer and 8, again we are supposed to do the bitwise operation. That is a final answer. Okay, here also if you have 4 numbers, first 3 and 5, you do bitwise operation, you will get one answer. Okay, again with that answer, do the bitwise for 7, again you will get one answer. With that answer, again you are supposed to do for 9. Like this, how the numericals will go on increasing, you are supposed to follow this procedure. Okay, bitwise means this is how you are supposed to do it. Okay, so that's about the array ordering method and array reduction methods. Okay, so that you have to verify array reduction method. Even if I do the simulation also, you have to do the bitwise and bitwise or bitwise XOR, and then only you are supposed to verify. Okay, just like that you can't check it actually. One second. See, array ordering methods in associative array, array ordering methods on dynamic array ordering methods on queues. Okay, all this you are supposed to verify once I complete the session. Okay, so here array reduction, sum and product, it is easy. So it will just give you the sum and the product. So here module and module, after again taken a fixed array. Okay, so 1 2 3 4 I have initialized the values. What is the sum? 1 plus 2 it is 3, 3 plus 3 it is 6, 6 and 56 plus 4 it is 10. So the sum will be 10. Product means 1 into 2 is 2, 2 into 3 is 2, 3 is 6, 6 4 is 24. 24 will be the product. Okay, sum and product. Let me run the code. But bitwise or and XOR, you have to do the simplification in the pen and paper, and then only you can verify. Okay, see, sum is 10, product is 24. That's what we have got. Sum is 10, product is 24. Okay, so and operation is there, you can verify it. Okay, even if I do C2, that's what 2 and 3 I have done the simplification here. No, what did I get the answer? 2 and 3 I'm getting 2 only. Okay, so that simplification I have done here. Okay, whatever the code I have written here in the file, 2 and 3, 10 comma 10, 10 comma 9 comma 8, 3 5 7 9. Okay, I think that simplification I have done here. Same answers I will be getting when I do the simulation, but you have to change the numbers. Do the simplification by yourself in the pen and paper and then verify. That would be better. Okay, simply just don't copy whatever it is there here. You do the simplification, then you will get a practice. Okay, yes. So that's about the reduction methods. 5 types are there, you have to memorize. Okay, when they ask array manipulation methods, you will first tell array ordering method, array reduction method, array locator method. Then again you should tell in the ordering I'm having 4 types, in the reduction I'm having 5 types, in the locator method again I'm having 2 types. One is element finding methods, again index finding methods. 2 are there, again you have to list out all those. Okay, so this is little bit almost theory only. Okay, you have to memorize this, because in the interview definitely they will ask you to list out. Okay, as I told, in the array locator methods, okay, we are having element finding methods also, index finding method also. Okay, one second. In the element finding method, element means what I'm writing inside the location that I want to find, means in the element which is a unique element, which is a maximum, minimum, first element, last element. Okay, find. And this, let me first directly I'll open the code itself. Okay, and I'll do the simulation there only you will understand. Okay, next in the index, again same thing, first index, find index, find index, first last index, and a unique indexes. Okay, unique indexes I will show what exactly is that. Okay, so this you have to actually remember, because it is useful. Why it is useful I'll tell. First let me okay, that's fine. Here okay, array iterate, no, not this one. Array ordering, element finder method. Element means what I have written inside. Okay, now, so from here onwards I'm so slowly inclining. See, this much complication code is not required, but now I have taken a little bit complicated code, because it will become easy for you to understand the class based concept from now onwards. Okay, but this much complicated code you no need to take. A simple code also you can take and you can verify, but now itself if I start explaining some complicated codes, you will become habituated. That's it. That's why I'm just explaining this. Okay, now here I have taken class and class. Inside the class I've declared some 2 variables. Okay, a and b, and I have written some function. In the function I'm just trying to display a and b. Simple. I didn't write any logic at all. Okay, now what I'm trying to do is, see, for this class, what is the name of the class? The name of the class is packet. Okay, now inside the module end module, I am declaring the handle for the I'm declaring the this class name I have written here. Okay, and I am declaring the associative array. So how, ma'am, how you are telling it as associative array? Because you can see the star here, right? See, if you write star also, if you write data type also, that is representing the associative array only. Okay, next, for this class I am creating one handle or pointer. How to create means, see, handle, instance, pointer, all these are similar words. Okay, but how to create an handle means simple. Just declare a name of that class followed by one random user defined name. When you write this, it means that this is a handle that is pointing to this particular container. Okay, and remaining variables I have taken one queues, I have declared one variable, I have declared one count. Why I have taken, you will get to know here in future. Okay, next, in the initial begin end, I have written object. So I have created an object. I mean to tell, this is a container. Okay, for this container, first I have created a handle. The name of a handle is packet. For this packet, I am creating a memory using the new constructor. Then it is called as object. Okay, what is handle? Handle is just a pointer that is pointing to the class. It is not having the memory. What is object? Object is something that is having the memory. So this is object, this is just a handle. Okay, so here we found one more important interview question: difference between the handle and the object of the class. Actually, this is a class concept, now only I'm explaining. Okay, it will come in future. Once again I'll explain, maybe tomorrow or the day after tomorrow. Okay, so difference between the handle and the object is very important. Okay, now, so I have created object. Why? Because I want to draw some picture like this. Here only I'll draw where I have written the diagram. So why exactly, what exactly I wanted to do means, in the second location, I want to keep that container, that object container. Inside that object, what is there? A value is there, B a value is there, correct? See, if you take a class, this is the advantage. See, that object is pointing to this particular container. Inside this container, what variables are there? Two variables are there, correct na? Then in one location, two variables also you are placing. See how much we have improvised, right? See, in one location we can store only one element, but here we are making use of an object of the class. This is the object of my class. So with the help of object of my class, I can keep even 100 elements. If you want to keep in the same location also, you can keep. Okay, in the second location I'm having a and b. In the fifth location also I've kept a and b, a value, b value. In the sixth location and in the ninth location, that is what you are seeing here. Okay, so here, see, I've created an object. So pkt dot a means pkt. Inside the pkt we are having a. Yes, I am having. Inside that a, I am declaring some element now. 8 3. And this packet I am assigning to the associative array's second location. That's what in the diagram you can see here. This is the associative array. In this associative array, in the second location I have kept this container. In the fifth location I have kept the same container only, but a and b different values I'm giving. That's it. Okay, so that's what I have declared here. Next, using the queue. Now I'm using queues also. Why? Just to store my answers. Okay, I'll show what I'm doing with queues. That also I'll show. So here this is an associative array now. Okay, so why? What is the use of this queue now? So I've taken queue and I'm writing associative array, this array, associative array dot find with some condition. Item dot a is 2. Item dot a is 2, which means what? It want the item dot a means a should be equal to 2. In this location it is 2, correct na? This answer will be stored in the queue. Which location it is? Sixth location. Okay na? Here, associative, sorry, q is equals to associative array dot find with some condition. What is that? Sorry, not here. What is that condition? Item a equal to 2. Now q dot size. What is the size of the q? the size of the queue is almost as of now the size of the queue, whatever the size of the queue is there, that is assigned to a variable called count. Okay, now see, completely I am assigning the associative array to the queue, which means what, in the queue how many elements are there? 4 elements are there. Right now 4 elements are actually stored in the, actually assigned to the queue. Okay, now if I write q dot size, that size will be 4 because associative array size is 4. Q size also will be 4. That 4 is assigned to the count variable. Okay, next I'm trying to display elements of associative array for any r. Okay, so I'm trying to display for the count. So in this case, if you see, a is equals to 2, how many variables are there, how many locations are there? Only one location, correct? No, in the sixth location a is equal to 2, correct? That is what the print that I'll get it over here. Okay, so I is equals to 0, I is less than count. Count means whatever is the size of the queue, that will be stored in the count variable. Currently only for this line, only for line number 47, what is the size of the queue? Only 1, correct? Only 1. Of course it total size if you take, it is 4, but only for the line number 47 this is the size, which means was the size of the queue is 1, correct? Na, that is size 1 is been given here. Okay, and whatever the answer I get for this particular, that I am going to pop front. Okay, mean in the queue already this is stored. See, sixth location values are stored here. Here I am popping front. Using the pop front, I am going to pop out and I am going to print the result. Okay, I'm going to pop out and I'm storing that in the temp variable, and after that temp variable I'm trying to display. Okay, now till here I will comment and I'll show the output first. Run the code. I'm just showing how the application is there. Okay, see, element number only 1. Okay, a is equal to 2, b is equal to 6. See, a is equal to 2, b is equal to 6. This particular location I have popped out and I am printing it. That's it. Okay, so till here is it clear whatever I have explained? Have you people understood what I explained so far in the code? I've taken an associative array. That associative array's answer I am storing in the queue, and from the queue I am popping out and I am storing that in the temporary variable and I am printing it. Is it clear? Others? Nothing difficulty is there. That's why I have kept this diagram here. Okay. Next also same scenarios. Next, again same thing. Associative array dot find b item is equals to 6. B where is there? 6, 2 times is there. See, fifth location also, ninth location also. Now in the queue, how many elements are stored? Fifth location is also stored. Ninth location is also stored. Now what is the size of the queue? Size of the queue is 2. Then what is the count? Count is also 2. See here, 6. Okay, size is 2. Okay, count is also 2. Now the loop will run for 2 times. Okay, and 2 times also I'm popping out this one, these two answers, which fifth location answer, ninth location answer, both I am placing in here. Now I'm popping out and I am printing. Okay, if I run it, 2 answers I should get now, because b is equal to 6 in two places, fifth location, ninth location. See, 0 6, see, 0 6 1 6 1 6, correct? So like that I am supposed to check the answers. Okay, next, that is okay. Next, item a is equal to 2 and b is equal to 6. A equal to 2 and b equal to 6, only one location. Okay, am I able to print that? Only one location. A is equals to 0, sorry, a is equal to 2, b is equal to 6. Yes, only one location. Okay, next, a is less than 2, b is greater than 5. A is less than 2, 1 minute. A is less than 2, b is greater than 5. 2 elements, 0 6 1 6. Again 0 6 1 6. See, a is greater than 2, b is, sorry, a is less than 2, b is greater than 6. In that case, 2 elements, two locations mainly. Okay, so this is how I'm using queue supplication, associate to array supplication, and also the usage of the class object. Okay, with the help of one code you have understood everything. That is why it has become a little bit complicated. Okay, it's not like just to verify array locator method you don't have to go for so complicated code. Okay, simple code also you can take, but here in this code what you have understood is, in one array element, that might be queues or associative array or whatever it is, if you want to store multiple elements, you can store it via object of the class. That clarity you have got now. Okay, see for example here I can keep still another 5 variables. That 5 variables element also you can place here in this object. Okay, see in this, for this location it is just one container, but inside this container 100 elements if you keep also it will take. Getting my point? Okay, so that is an advantage of creating a class. Okay, see in the verilog stage, okay, we used to keep only one element, we can't keep multiple element 100%. But when we start using the class like this, we can have in the same location, we can have multiple elements that you can keep. Okay, so this is how the advantage is there for the class based concepts. Okay, yes. So likewise, you can also analyze for the index finding methods. Just now what I did for element, same code only, but I am now finding it for index. Array dot find index. Okay, like that if you find, once you analyze that index methods, you have to analyze it. Okay, same code only, same diagram, but this time I will be finding for only the index. Only a index output you will get. Means for example, b is equals to less than 2, and a is equals to less than 2, b is equal to greater than 5, means index, which index, index 5, index 9, that index output you will be getting. That's it. That's the only difference between the element and the index finding methods. Okay, so in the same methods. And here what is unique means, see I'll tell what is this unique. For example, you have an array. Okay, and 44, 44, 8, 8, 11, 12, you are having the elements like this. Okay, 0, 1, 2, 3, 4, 5. Now if I tell unique index means, see 44 repeated two times actually, correct na? But only this location I will take 0. 0 is a unique address. Next, 8 also repeated two times, I will take only 2. That repeated index I don't take, because I want only the unique indexes. Okay, next, fourth location I will take, fifth location I will take, because 11 and 12 anyways it didn't get repeated, I will take. These are the unique indexes. If I tell unique element, then 4, what is that, sorry, 44, 8, 11, 12, these are the unique elements. These are the unique indexes. In the unique indexes, remember, always the first index you will get. Even you are repeating the element for 3 times also, first element whatever it is there na, that particular index only you will be getting it. Okay, yes. So that's about the unique. Oh sorry, just a minute guys, just a minute. Call actually, yes. Okay, okay, so that was about the element and the index. Okay, so this you people have to put some efforts, and so many codes are there. Okay, you have to analyze same code only, but I have changed the inbuilt methods. Okay, here what inbuilt methods are there? Where is that? Here index inbuilt methods are there, index inbuilt methods I have used, but the same code only. Okay, same logic, only inbuilt methods I'm changing and I'm extracting the output. Okay, so that's how exactly I'm doing the things. Okay, now, so that's about it. And coming to the next concept, iteration, array iterator index querying, and 1 minute. Here 1 2 3 4 5 6 are there, and here see elements minimum maximum also. So in the array which is the minimum element, okay, same example in this, which is the minimum, 8 is a minimum element, so that output you will get. Okay, that is a minimum, and maximum element means in this you can take it as 44. 44 is a maximum element. Okay, so that's how we will be able to get the things. Okay, task, but still you can make a note. Okay, so same like this previous method, array, what is this, array locator methods. Okay, if you extend that locator methods you will get these methods. Okay, it means like array dot find with item means your element, item equal to item dot index means element and the index both should be same, then you will get the output. I mean to tell, 0 1 2 3. This is my locations. Okay na, these are my locations. Inside the element, suppose if I write 44, 55, 552 and 104, I write something like this. Okay, here what exactly will happen is, 1 minute, what happened to this put for this. For example, if I write 0 here, so element, item means element here, element and elements index both are equal, correct na? So that output you will get it over here. Getting my point? Element and elements index both should be equal. Okay, in this case only, for this you will be able to get the output. Okay, that you are supposed to make a note. Okay, next, element is greater than element dot index. Always this output also you'll get, this output also you'll get, this also you'll get. Element, item means your element, element is greater than your index, correct na? 55 is greater than 1, 542 is greater than 2, 104 is greater than 3, correct no? So in these three cases also you will be getting this particular output. Okay, and item is less than item dot index. This item is less than item dot index means, for example, you can take it as okay, here you can keep it as 1. Okay, so in this case you will get this output, means item element 1 is less than 2. Okay, in this case you will get this output. So these three scenarios are there for array iterator index querying. Okay, so this also you can make a note. This is extra, actually extension, it's an extension of the array locator methods. Okay, yes, people will be actually studied there. Okay, that also I'll teach now itself, because control flow elements, it is easy guys, which you already know, but few extra keywords are there. Okay, those extra keywords I will discuss now. Okay, so here the going to happen is like for loop, for each. Okay, you can see over here. Okay, so here what exactly is happening? So in the control flow statements, okay, so unique if priority if, which you don't know so far, okay, because in the Verilog you have not come across this. Okay, but in the Verilog, while, do while, for, extended for I will show. Okay, repeat, forever, all these we have discussed right now. I mean, you people have already learned, right? And from C language we are taking break and continue. Okay, so these are little bit new concepts. Okay, now 1 minute. Unique if priority if I will show directly in the code. Okay, there only you will understand. Unique if priority if, unique case, priority case, that I'll show. Remaining which are easy to you, first let me complete that. Okay, so while and do while. See, usually as I told, system Verilog is a combination of multiple programming language. I already told, right? That right now, so from C, C++, Verilog. Okay, from multiple programming languages we are taking the topics, best topics. Okay, that is what is actually the system Verilog's agenda. Okay, in that particular agenda, this while and do while, whatever it is there na, this while and do while is actually belonging to the C language, which we already know right now. If you people know C, definitely in the college level you people will be knowing C language right now. While and do while we have actually captured from the C language. Okay, see the syntax. While, whatever the condition is there, you will write inside the beginning, the logic will be written like, while if A is greater than sorry, if A is less than 5. Okay, so this loop will get entered and these things will get executed. Okay, here do while, in the do while what happens, first logic will get executed, then I'm checking the condition. Okay, so like this the syntaxes are important. But ma'am, are we using these loops in the system Verilog? It's not like we are not using these loops, but these loops are, these loops can also be used in the system Verilog. Okay, it's not like compulsory we are not using this. Okay, but if required we can use, means system Verilog is supporting for the C language loops also. That is what I meant to tell. Okay, next, enhanced for loop means nothing. For loop means for I equal to 0, I is less than some a loop, iteration loop, and I plus plus. But here you can have two variables, that is called as enhanced for loop. That's it. Okay, at a time you can give the value for two variables, I and j. See, I and j, here also I and j. Okay, you're trying to initialize the values, you're trying to increment and decrement. Okay, and you are writing the loop. Here also can I write two variable? Yes, you can write. Okay, when you are giving two dimension variables in the for loop, that is called as enhanced for loop. Okay, I'm just giving you people the exploration of extra things. Okay, next, jump and jump statements. Under the jump statements there are two things, break and continue. This is there, I'll show in the simulation, these are there. Okay, so break means you want to break the loop, means in between the loop you want to come out, then you can use break. Continue means you have break it but now you want to continue, then we can use continue. I'll show that in the code. Okay, I'm just telling the normal explanation, theory explanation. Named blocks and statement labels means usually when the code is very lengthy. Okay, when the code is lengthy, in that point of time you will be getting these named blocks and the statement blocks. Because I have written the begin in the line number 100. Okay, after some 150 lines in the line number 151 I'll be writing the end. Then how do I get to know where is begin and where is end? Means in the code we will be having multiple begin statements and multiple end statements we will be having, that is 100% sure. Then we will not get to know na where is begin, where is end. Correct na? That is why we are using this block names. Okay, means for example a1, a1 like this. If I write, I will understand. Okay, a1 block is going to start here and a1 block is going to end here. Like that I will get to know the things. Okay, that is what is happening in the named block. Okay, statement block usually we will not use. In the statement blocks nothing like comment means in the, if you want to comment anything, what you will do, here you will write forward slash star and here you will write star forward slash. Correct na? The same way statement name is used, statement name. Okay, after the end you will write statement name. Both are almost same only, but usually we almost write the block names more. Okay, we implement more block names rather than statement names. Okay, so that's how it is. Okay. Hmm. Next, if you want to disable, can you disable that? We okay, randomization concept has not come. Next week when I explain about the randomization, you also get to know that disabling is also done actually. Okay, even if you want to disable the processes, you can definitely disable. Okay, that you will get to know in the further next week sessions. Okay, now only the loops can you disable? Yes, definitely you can do, but how? If you want to disable the loop, compulsory you should give the name for the loop. What kind of name? This is what I'm telling about. Name. These names. Okay, these names you are supposed to compulsory give it. Okay, so that's what is called as begin end. Okay, I have written, but name you should give. If you give name, then only with the help of that name you can disable that. Disable this particular loop. Getting my point? If you do not use the name, you can't disable it. That's the problem. Okay, if you want to disable, compulsory the name should be given for that particular loop or for that particular block, whatever it is, that is a block or that is a loop, you are supposed to give the name, then only it is possible for you to disable it. Okay, next, event controller everyone knows, always block. Okay, but in future you will get one concept called events. In that I will tell what is the difference between at and wait. That is different concept, this is different. This is a normal verilog concept that I have written here, that always at positive edge of a clock, always at negative edge of a clock, or always at the star. This is different. Okay, this is different with the thing which you will learn in a future classes. At and wait is totally different. Okay, yes, so these things are common which you are already aware of it. Okay, now let me tell you which you are not aware, like unique if priority if, unique case priority case. Okay, one minute, one message I'm getting, just a minute. Just a moment. C40 I have given some of the variables, initialization values I have given here. Okay, unique if Okay, I have written some condition. Okay, unique if a is less than b, a is less than b, yes, it is true, correct na? I have written one statement. Next, else if a is less than c, a is less than c, this condition is also true, correct? I have written some I have written some display, else I have written another display. Okay, first let me run this. So here what is happening, see, I want unique displays or I want unique conditions, but here both the statements are correct, right? See, when both the statements are correct, I am getting line number 12 and 13 are overlapping, isn't it? See, line number 12 and 13 both are overlapping. Of course it is overlapping. Line number 12 and 13 both are overlapping. Why it is overlapping? Because like a is less than b, that is also the true condition. A is less than c, that is also the true condition. Both are true condition, so the lines are getting overlapped. Getting my point, ma'am? Like why and where exactly this application is used means, see, in the industry level of coding, so many lines of codes we will be having. Okay, so many lines of codes we will be having. When we have so many lines of codes, what exactly happens is, unknowingly as a programmer we will write some displays which is repeating too many times. Means we are writing such conditions which is true so many times. Okay, but in the output we will get only one display. To avoid these kind of mistakes, or to understand for the programmer, means when I write the conditions, I should write unique conditions, correct na? When I write the condition something like this, if I get the error like this, it is actually not the error, the code is running. Okay, it is like warning message. When I get the warning message like this, I can understand, okay, I have given the repeated conditions. Okay, I can get a clarity like that. For getting that clarity, I'm having this unique if. Okay, so now if I go for priority if, now I'm going to prioritize. It's okay, even though multiple times if I'm having the display also no problem, multiple times if I'm having the same condition also no problem, I just want to prioritize my first display. Okay, so what is that? Here priority, I'm using priority condition. Okay, here I'm prioritizing any one statement. Of course both are correct only, first statement is also true, second statement is also true, but I will prioritize my first statement. Okay, if I run the code, okay, see, okay, wait a minute, here what is happening, no condition matches. Oh, okay, values I have given different. See, a is less than b. Is it true? No. A is less than c, a is less than c, it is also not true, so it is giving me no condition matches. Okay, suppose if I give the same values like before, 10, a is less than b, a is less than b, it is correct. A is less than c, that is also correct. Now if I run the code, see, a is less than b I'm getting, which is my first statement. See, here both the conditions are true, but I am getting a prioritized condition. Getting my point? A is less than b condition only I am getting. Okay, that is what is called as a priority if. In the unique if, I should definitely, see, name itself tells unique, means I should definitely write the unique conditions, that is compulsory. Okay, in the priority I need not write the conditions which is unique. You can write the repeated conditions, but you can give the priority for the first statement. Okay, so is this clear? Unique if, priority if difference? Yes, unique if, priority if difference, is it clear? Are you people there listening or slept off? Yes, yes. Okay, next, unique case. So for one, condition is only not there. Okay, have I written any condition for one? I have not written a condition only. Okay, actually I should write here, no, like this one I should write. I didn't write one only. Okay, I have written the displays for zeroth condition and the second condition. Okay, I'll run the loop. I'm sorry, I'll run the code. See what I'm getting? No condition matches in the unique case. Correct. Suppose if I give 1 here, 1 here, here also I will give 1 only. Okay, two conditions I have given for the same case. Now what I'll get? Line number 8 and 9 are overlapping. Correct na? Here also it will avoid the programmer's mistake. Okay. Now if I give this as 0 and this as 1, enter. Now I will get the last statement found to be 0. Okay, means here by simply, if instead of using case, if you use the unique case, your mistakes will be pointed out. That's it. Getting your mistakes will be pointed out. That's the important thing here. Okay, that you can remember. Okay, you can use normal case only, but if you use unique case, what is the advantage? Means multiple values if you have written, means in the question you have written the same numbers again and again and again, means it will indicate that array you have written multiple conditions, same means same value you have written multiple times, it will tell you. Okay, that is that is very important here. Okay, so here you are getting found to be 0. Here this one, once again this one found to be 0 you are getting. Okay, so for 1 you have written, suppose if you have written 2 times, if you have written 1, means it will indicate you, but in the case statements that won't happen. See, for example, if I, that will give you the error. See, you should not, if you get error, that will be a problem in the simulation, in the lengthy simulation. See, I have removed unique, I simply used case statement. Okay, so here what you will get is ABC value is 1 only. Okay, see, you are getting found to be 0. That is wrong na actually. Means it should indicate your mistake na. See, 2 times you have written. If you use a normal case statement, it is not indicating your mistake. Simply it is giving you the value. Okay, and as a programmer, you will not recognize your mistake. Okay, if I use unique, it will point out your mistake. See, line number 8 and 9 are overlapping. 8 and 9. These two are overlapping. Right. So that's what will happen here. Okay. So this thing, please make a note of it. Okay. It is actually overlapping over here. Okay. What is that? It was a unique case. Okay. In the priority case, it will prioritize. Okay. If I remove this and if I priority, and what is the difference between priority case and unique case? Nothing now. Okay. So if I write priority case, it just behaves like a normal case. Okay, so priority case is not used application wise. Okay, see, it is giving the priority for the first statement, which means what, like a normal case statement it is behaving. Okay, so I'll not be using this application wise. If I want application wise usage, I'll be usually using the unique case. That is more beneficial for me. Okay, that's about the things. Okay, so you can go through it. Okay, for each already we have discussed in the arrays concept, like where we are using for, where we are using for each. Okay, repeat loop, forever loop. Okay, if you are using forever loop, compulsory you should use dollar finish. If you are using a repeat loop, no need to use a dollar finish. Why? Because in the repeat, compulsory you are writing that number, that 4 times it should get repeated, 5 times it should get repeated, you will write it. But in the forever loop you will not write that, you should compulsory write the dollar finish. Okay, means when it has to end, you have to write that actually. Getting my point? Okay, so that is about the thing. So here if I write the interview question, object and difference between what is the difference between your, the forever we have to use the dollar finish. Okay, or else the loop will run forever. Okay, so 2300 times the loop will run and it will stop in the sense it will not stop. That is the capacity of the question sim. Okay, I think in the EDA it is 500 and something. Okay, those many lines you will get and it will stuck there only, it will not stop, it will get stuck if you do not use dollar finish in the forever. Okay, so all these codes, even all the simulation one by one, you are supposed to do it. That itself is your assignment for today. Okay, because so many codes are there related to your array manipulation methods and the control flow methods. Okay, yes, so I'll